So, last class we always had, first of all, we always had quadratics that were factorable. They were also always in standard form for us. So a quadratic equation must be, fill in the blank for me.
Set equal.
Yeah, set equal to 0. Whoop.
How far in the packet is this?
It is on the second page within the quadratic formula notes. So if you go to the page that says quadratic formula.
Like halfway down the page.
Quadratic formula notes.
Right here?
Nope. So,
it's on the bottom.
when it has solved 2x squared plus 7x equals negative 3, what do I need to do first?
Set it equals to 0.
Well, yes, I need to set it equal to 0, but how?
Add 3.
Add 3. So I add 3 to each side, and that's going to give me 2x squared plus 7x plus 3 equals 0. And then that's going to allow me to identify my A, B, and C values. So it says right here, A is 2, B is 7, and C is 3. Do you agree with those values?
Yeah.
Okay, does it make sense that if you didn't move that 3, you'd have the wrong C value? So substitute those values into the quadratic formula. So again, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, you have to have that memorized. That's half the battle. You gotta have it memorized. So, sure.
Yes.
No, it's 2 squared minus 4.
There's no M's or elemental P's. Okay, so x equals, Tim, negative b. What's that going to be? Negative 7 plus or minus the square root of 7 squared minus 4 times my A value, which is 2, times my C value, which is 3, all over 2A, or 2 times 2. Yeah, horrible color. I'll switch it back to black.
Thank you.
So let's clean that up a little bit. X equals negative 7 plus or minus the square root of what's 7 squared? What's 7 squared?
49.
49 minus 4 times 2 times 3, 24. All over 2 times 2 is? Okay, cool. So then I have negative 7 plus or minus the square root of 49 minus 24? 25. All over 4. The square root of 25 is? 5. So I have x equals negative 7 plus or minus 5 over 4. So now I'm ready to get my answers. So I have negative 7 plus 5 over 4. What's negative 7 plus 5?
Well, that would be negative 2.
Negative 2 over 4, or negative 1/2. Good. And I have negative 7 minus 5 over 4.
Negative 12, which is equivalent to
Good focus.
Negative 3. Good. Negative 12 over 4, which is going to give me negative 3. Is this going to be something that would have been factorable?
No.
Yeah, sure. Would have. Negative 1/2 and negative 3. Those are nice, pretty numbers. No radicals in there. That would have been something that is factorable. If I could have factored that quadratic. If it was a parabola, where would it have crossed?
At -1/2.
And at -3. Those would have been the intercepts. Good. Okay, flip the page over. Oh my gosh. Okay. On the next page, example A, you see 3x squared equals -x plus 10.
She's writing on a glass recording, aren't you?
Because I'm not here tomorrow, and my B-Block kids will have to take notes through the computer.
Wait, so
Oh,
can they
wait,
hear
wait,
me
so,
right now?
so this is gonna be like on, like they can like hear this?
Yeah.
Oh, nice. Okay.
So,
Hey, Brendan. Who uses a pineapple under the sea?
So, yeah.
how would I get this set equal to 0?
You do -x and 10 to the other side.
Yeah, so, but here's the other thing. Because I'm using the quadratic formula and I'm not factoring, I can also just subtract 3x squared. It doesn't matter now. It doesn't matter if my x squared term is negative. So I have some choice. I can either subtract 3x squared or I can add x and subtract 10. It does not matter which way you move to get it set equal to 0. So what do you want to do?
Subtract x squared.
Sure. So let's get it set equal to 0 by subtracting 3x squared. So then I get -3x squared minus x plus 10. So that's going to give us an a value of -3, a b value of -1, and a c value of 10. Now, if you had done it the opposite way, obviously you would have had some different signs, but you'll end up with the same end result. So it'll be okay. So, x equals -b plus or minus the square root of b squared. Are you okay with the fact that I said b was -1?
Yes.
So -x is, my coefficient is -1, minus 4 times my a value times c all over 2a. X equals 1 plus or minus the square root. -1 squared gives me 1. -4 times -3 is going to give me +12. Times 10 gives me +120. All over -6. That's going to give me 1 plus or minus the square root of 121 over -6. Well, what's the square root of 121?
11.
11. So I have x equals 1 plus or minus 11 over -6. So x will equal, well, what's 1 plus 11?
12.
12.
So -2.
So -2 is one answer. 12 divided by -6 would give me -2. 1 subtract 11 would give me -10. -10 over -6. Negative over negative would make it positive, and it reduces to 5 over 3. Good. Again, this would be factorable. It's not like I have like a radical answer. Okay? And in fact, you can kind of work backwards to find your factors. So this may, like some of you may get this. Some of you probably won't, but some of you may get this. Don't have a ton of space. Let me rewrite it on the next slide. So if my solutions are -2 and 5/3, if my solutions are -2 and 5/3, well, if I know my solutions is -2, then that tells me a factor is x plus 2. Does that make sense? And if my other answer is 5/3, then that means that I subtracted 5, I added 5 over, so it was -5 originally, and I divided by 3. That was my factored polynomial.
That's just rude.
Phew. Do you see what I'm saying? Like, if you had your answers, you could work backwards to get your factors. So, if I knew my answer was -2, then my factor was x plus 2. And if I knew my answer was 5/3, if I worked backwards from that, that meant I divided by 3, so it had to have been 3x, and I added 5, so it had to have been -5. I have to flip it. That's like, that was a real big extension on that, but yes, it is factorable, and in fact, this is what it would have been factored.
What's the point of doing that?
Because then, say you didn't have the original problem, but it said, here are my solutions. You could say, okay, so here are the factors. So then 3x squared minus 5x plus 6x minus 10. This is the polynomial you started with. I could work backwards from the solutions to the polynomial.
Well, we have to do
Not today.
that.
No.
Okay. So, you see B there? I see B. You see B? I see B. You see B? When I subtract 13x, where should it go? In between, not in the trash. In between 2x squared and 21, it should be like 2x squared, subtract 13x plus 21. Okay, because that would be my bx term. So make sure it's written in standard form. I want you to go ahead, do the quadratic formula, determine a, b, and c, get it set equal to 0, a, b, and c, quadratic formula, it, get your answers, go. Alright, so I subtract 13, and when you do that, it should look like this. Because you want it to be in standard form, ax squared plus bx plus c. Make sense?
Yeah.
So then a is 2, b is -13, and c is 21. Plugging that into the quadratic formula, x equals -b makes it +13. B squared minus 4ac all over 2a, or x equals 13 plus or minus, what is 13 squared?
169.
You're sure. I made my D
That's mine.
21 somehow.
Huh? Oh, that's because you didn't put it in standard form. Thank you. When you write a quadratic, it needs to be in the form ax squared plus bx plus c. Ooh.
Oh, so that x.
So the x term has to be in the middle. Yeah.
Oh, I get it.
What's 13 squared?
169.
169. And then when I do -4 times 2, it's going to give me -8 times 21 is going to give me -168. 168 all over 4. What is that? That's going to give me the square root of 1. The square root of 1 is just
No, I did 21.
1. So I have 13 plus or minus 1 over 4.
I got this all right. I'm so excited.
So, that's good. So, let's see. Running out of space. 13 plus 1
7.5.
would give me 14 over 4, or 7 over 2. 13 subtract 1 would give me 12 over 4, or 3. Good. Now, let's play that game.
Game?
Yeah, it's called...
Get your hopes up.
It's called math. We just... We just said,
I hate playing that.
I know. We just said that our solutions were 7/2 and 3.
You can't see anything.
That's the glare.
Maybe glare.
Doesn't matter.
We just sing off your
It's gonna be the other classes.
We just sing the song. We sing the song. Yeah. Oh, sure. Yeah.
That is so funny.
Whoa.
Mister, do you have the light on in the elevator? I swear.
Yeah,
Do I have to report you to the police?
because I'm dabbing.
Yes.
No. Okay,
That is not allowed.
so we just said that our solutions are x equals 7/2 and x equals 3. Yes?
I guess so.
Affirmative.
Let's start with the first, or the easier one, x equals 3. What does that mean that a factor then would be if I had factored to solve?
1 and 3?
No, meaning x equals 3,
Oh.
the factor that I would have had if I had factored to solve would have been x
Minus 3.
minus 3. Good. Now let's look at this one. What does this mean? Divide by 2 means I would have had what? 2x, and positive 7 means I had
Negative.
-7. This is the factored form of that polynomial, working backwards from my answers. Mind blown. Okay? So, it says, critical thinking. Solve each of the equations you just solved by using the quadratic formula by factoring instead. So these are the same equations we just solved using the quadratic formula.
Why are we doing anything?
Well, we're going to compare and decide which method we prefer and why do we prefer it. So if I have 3x squared equals negative x plus 10, now if I'm going to factor, I have to keep the x squared term positive. So if we're going to factor, we have to keep the x squared term positive. So I have to keep the 3x squared right where it is, and this time add x over and subtract 10. So factoring. Hopefully we still know how to do this. 3x squared, sorry. 3x squared we're going to break apart into 3x and x. Negative c value, that tells me that it's opposite signs. Okay? I need factors of 10 that will make this OI to 1. Factors of 10, negative 5 and positive 2. That's going to give me negative 5x, positive 6x. So then when I go to solve, 3x minus 5 equals 0. Gives me x equals 5/3 and x equals negative 2. Is that what we got when we did the quadratic formula above?
Yes, ma'am.
Yes. Okay, here, again, get it set equal to 0. And now, instead of using the quadratic formula, we'll factor.
I like this way.
Yeah, it's just really
2x and x, positive c value with a negative middle term, negative and negative. I need it to OI to 21, or I'm sorry, OI to 13, factors of 21.
7 and
Miss Fleur, isn't this like the same as what we were just doing?
7, yes, we were just factoring. So that gives me negative 7x, negative 6x, yes. Then this adds up to negative 13. So then when I go to solve, this would add 7, divide by 2, gives me 7/2, and x equals 3. Okay? So exact same solutions, different method. Then underneath it says, which method do you prefer? and y.
This y equals m.
Way easier.
So, which method do you prefer? Why? Raise your hand if you have a reason.
Quadratic.
But why? Because you like it better.
We've been working
I
on
like the
it.
quadratic formula. Easier.
Does anyone like the quadratic formula method for a reason?
Oh,
I love
It's
the
just because
I
it's
like
more
white
challenging than
No, the
and it's also like a
quadratic
pattern.
is so
It's a fun
easy.
pattern.
It takes guessing.
It's fun to sing. Okay.
I
Yes?
swear,
It's such a pattern. It's like a
What,
weird
Sam?
pattern.
So I like the quadratic formula because
No,
it
I
takes
actually didn't do that. I just like that.
Takes the guessing out of
it
it?
takes the guessing out of it.
The quadratic formula makes it so you do not have to guess.
Miss Sawyer, I literally spent
Leave
like
Miss
30
Sawyer.
minutes on question 2 on the test.
Yeah.
Because I kept guessing.
Right. You don't have to guess with the quadratic formula.
That's I like.
Isaac.
For the quadratic formula because it will work with all.
Anything. Yeah. Like last class I said any stinking quadratic. Exactly.
Stinking.
Stinking.
It's on video. She can't
Is
say
that
it.
a bad word? She can't see the answer.
Yeah, she's on video.
Nicole.
Mackenzie's watching.
Oh.
Technically, yeah.
Yeah. Greg.
For like the problems of math, it would be 3 over 5.
So you have to skip a couple pages and you see this little grid. It says solve using factoring, solve using the quadratic formula. So we're just going to kind of compare and contrast and make sure both our answers match. So if I have 4x squared subtract 13 plus 3, if I were to solve by factoring, and a lot of you said it takes the guesswork out, right?
Yeah.
So if I were to solve by factoring, I'd have to sit here and think, okay, well 4x squared, it could be 4x and 1, or it could be 2 and 2.
It's gotta be 4x and 1.
You think
Yes,
it's,
2
you
and
think,
2.
so you think it's 4 and 1?
Wouldn't work out.
Yeah.
And then it's a positive c value with a negative middle term, and I need 3 and 1. So what do you think?
Just put 3 on the outside. So minus 3
Mm-hmm.
plus 1.
Nope, they're both negative.
Or yeah, alright, so negative 1. and
Negative 12, negative 1.
Yeah.
Okay, good. So that gives me x equals what?
17.
Woo.
13.
X equals, when I set them both equal to 0, I give the first factor would give me x equals 1/4, and the other factor would give me x equals 3. That's solving by factoring. Okay? Method what? Solving by using the quadratic formula, well, A would be 4, B would be negative 13, and C would be 3. Okay? So I would have x equals 13 plus or minus the square root of negative 13 squared minus 4ac over 2a. So a lot going on, but I'm not really thinking. I'm not really guessing and checking. I'm not having to really like do a lot of mental math.
Mister, why don't we just do that like method where like you put a big X on your paper?
Because we're not. That's not a good answer. Negative 13 squared gives me 169. This is going to give me 16 times 3.
16 times 3?
Minus 48. Over 2 times 4 gives me 8. X equals 13 plus or minus the square root of 121 over 8, and we've already seen the square root of 121 is 11. And so now I'm down to my answers. So 13 plus 11 would give me 24 over 8. 24 over 8 is 3. 13 minus 11 would give me 2 8s.
There's
And-
a little more work involved with the
2 8s reduces to 1/4.
yeah, but
Yeah, more lengthy.
It's like more accurate though.
Lengthy, but less kind of mental math.
The guess and check is not the way to go.
Okay, more accurate, less mental math. So now I want you to do the same thing for the next one on your own. Solve by factoring, solve by quadratic formula. You better get the same answer.
This or
you better get started, man.
You better.
On the
This or
test.
Okay, so Solving by factoring, you get 2x minus 1 and x minus 3, which solves to 1/2 and 3. Solving using the quadratic formula, you get the square root of 25 underneath your radical, which is 5. So then you get 7 plus 5 gives you 12 over 4, which is 3. And 7 minus 5 gives you 2 over 4, which reduces to 1/2. So you get the same answers, different method. Okay, so last thing we need to look at, we're actually going to look at 2 different things, is looking at quadratics that do not have perfect squares. So I didn't take a picture of this in here, but if you flip back 1 page, it says solving quadratics that do not have perfect square roots.
Where does it say that?
And the problem that's on your page is 2x squared minus 3x equals 8. So if it does not have a perfect square root, then it's not factorable. If it does not have a perfect square root when you do the quadratic formula, then it's not something that's factorable.
How's the drinking time?
So setting this equal to 0, I would get 2x squared minus 3x minus 8 equals 0. Do you agree with that? Setting it equal to 0. So that gives me an a value of 2, a b value of -3, and a c value of -8. So you just flip back 1 page, guys. 1 page. Says 3, solving quadratics that do not have perfect square roots. So, solving quadratics that do not have perfect square roots, what does this look like? So substituting it into my quadratic formula, x equals -b. So if b is already negative, it's going to make it +3. Plus or minus the square root of b squared minus 4ac all over 2a. X equals 3 plus or minus the square root of 9 plus, so I'm going to have -4 times 2, which is -8, times -8 would give me +64 over 4.
Which does not equal a perfect square.
Right, so that's going to give me 3 plus or minus the square root of 73 over 4. So then the only thing I want you to do is then see if I can prime factor that to simplify the radical at all. So I would take 73 and see if I can fit any prime numbers into it, but I don't think I can. Like 73 is not divisible by 3. It's not divisible by 2, not divisible by 5. I can't do anything with that, okay? So now I'm just going to leave it. If I could simplify the radical, I'd simplify the radical.
So
If I could reduce anything, like if I could reduce my, like if this was 2 over 4, I could write it as 1/2 plus or minus square root of 73 over 4. I'd do that if I could reduce any of my fractions or anything.
So if this comes up on a test, you just want us to circle it.
There's your answer. You could write it as 3 plus the square root of 73 over 4 and 3 minus the square root of 73 over 4. There's my 2 answers. But I don't want you to get the decimal answers because they would be rounded decimals. They wouldn't be accurate answers. Okay? The only time you're going to give me decimal answers with non-factorable trinomials are when we do application problems, when you're solving for time, distance, height, because then I want just like a rounded answer. Give me the rounded time. Give me the rounded height. Give me an approximation. Yes, Isaac?
Should we set the answer equal to 0 when we circle it or square it?
Nope. Nope, you're solving for x, so... I mean, you set your original equation equal to 0, but this is your solution.
And should we set the answer equal to x? When we...
Yeah, you can write x equals. Yeah.
Okay.
So let's look at another one. So if I have 3x squared minus 8x subtract 1 equals 0. That's example A below. That's already set equal to 0. Here's A,
Wow, that was a good
here's
save,
B, and here's C, right?
John. Good save.
So here's A, here's B, here's C. X equals negative B plus or minus the square root B squared minus 4AC over 2A. 8 plus or minus 64. This is going to give me plus 12 over 6.
Oh, we were just thinking about Mackenzie whipping and Nene.
X equals 8 plus or minus
Can we see that video again, I swear?
76 over 6. Let's see, 76.
Does not go, it does not work.
Yeah, but I can at least reduce 8 over 6, though. But 76, if I prime factor it, is divisible by 2.
Yes, sir.
It's going to give me 38 divisible by 2. It's going to give me 19. So what is 76 simplified to? 2 square roots of 19. So I can rewrite, can I go to a new page?
Yes.
Okay, instead of 8 plus or minus the square root of 76, I can write it as x equals 8 plus or minus 2 square roots of 19. And they're each being divided by 6. Sam?
Yes, how may I help you?
So I can reduce those fractions now. That's my last step in terms of getting the most simplified answer. So now I've simplified my radical. What is 8 over 6 reduced to? 4 over 3. Plus or minus 1/6 reduces to
It's 1/3.
1/3. So I just have 19 over 3. There's my simplified answer. Okay, so tricky stuff.
6 reduces down to.
Did I? Sorry. 2/6
Silly
reduces
goose.
down
Alright,
to.
Mackenzie whipping and Nene.
I want to hear her sing the song.
Okay. So we still need to look at vertical motion
We
problems.
can do that later.
Mister, honestly, if like you teach us it now, by the time we get back to break, we're talking about
I know.
So true.
So I'm giving you